From the previous part of the question, we have three roots for w, and the first one is w is equal to 3 that is given to us by the question. So for w to be equal to 3, let's try to re-express this into the modulus argument form. The modulus of w here, which is going to be modulus of 3, this is just going to be equal to 3. And as for the argument, if I were to just try to sketch 3 on an Argand diagram, 3 is going to be here. So the angle that is with respect to the positive real axis is 0. So the argument of 3 is going to be equal to 0. This tells me that w is 3e to the power of I 0. For the other root, it is w is minus 3 over 2 minus 3 square root of 3 over 2i. So for this, let us try to find the modulus. So modulus of w is modulus of this, which is going to be square root of minus 3 over 2 square plus minus 3 over 2 minus 3 square root of 3 over 2 square. And this will actually still give us a 3. And as for its argument, let's try to sketch this on an Argand diagram. On an Argand diagram, it is going to be in the third quadrant. Third quadrant, because here is going to be minus 3 over 2 and here is going to be minus 3 square root of 3 over 2. So the angle that we are looking at is this, which is going to help us to represent the argument of w. So it is going to be minus pi plus the basic angle, and the basic angle will be tangent inverse of 3 square root of 3 over 2 divided by 3 over 2. And this will be minus pi plus pi over 3, which will give us a minus 2 pi over 3, which means that for this particular root, w is going to be equal to 3 e to the power of minus I 2 pi over 3. As for the last root, we are looking at w to be minus 3 over 2 plus 3 square root of 3 over 2i. And in fact, we don't actually have to calculate the modulus and argument from scratch, because this and this, they are just conjugate of each other. And if they are conjugate of each other, that means w will share the same modulus and the argument will be negative of each other. So it will be e to the power of negative of this, which is I 2 pi over 3. And what we are supposed to do is to represent these three complex numbers on an Argand diagram. So if I were to let A to be a point that represents this, so A, I'll let it represent 3e to the power of I 0. A is going to be somewhere here, A, and the distance from the origin, it is going to be 3. And I'm going to let B be a point to represent this complex number. So for this complex number, we will represent it with B, which is e to the power 3e to the power of minus I 2 pi over 3. So the distance away from the origin is 3. The angle that it makes with the positive real axis is minus 2 pi over 3. So we have something like this. Let's say it is going to be here. This is going to be point B, and the angle that is formed here is minus 2 pi over 3. The distance away from the origin, this distance is 3. And I'm going to let C represent this complex number, 3e to the power of I 2 pi over 3. So the point C is going to be a distance of 3 from the origin, and the angle that it makes is going to be 2 pi over 3 with reference to the positive real axis. So C is going to be somewhere, let's say here. The distance is going to be equal to 3, and the argument that it makes with the positive real axis, it is going to be 2 pi over 3. And because these two, they are actually conjugates of each other, which means that another reference that we can try to sketch onto our Argand diagram is that if I were to draw a straight line from C to B, this straight line is going to be 90 degrees, since they are supposed to be a reflection of each other about the real axis.